Okay, so before we move to questions from the audience, as a tradition by now, I'll start asking questions myself and start with this more historical question. So you are a mathematician, not a physicist like many of our guests, so a mathematician that's working on pure theoretical computer science, automata theory, then moved to database theory, dependencies and joins and formalization of those concepts, then to conceptual modeling, then to a broader sense of conceptual modeling, so modeling of hypertexts and web applications, and now to the theory of conceptual, or a general theory of conceptual modeling. So let's do that step by step. So how did you move from the automata theory, from being a mathematician to getting interested in database, in theory of database, in database aspects?
I think this was a very simple move. When I came back after my PhD, our Dresden leaders told me, you know, it is nice to do theory, but do something useful. Start to think about doing something more useful. And in his understanding, it was something what is useful for computer science or computer engineering. So, and he challenged a little bit more. He said, okay, fine, if you are not useful anymore, then search for another place to work. That means in this case, you have to think about such things. And then I started a little bit with theory of, let's say, in computer science, with artificial intelligence, funny stuff even for myself. I still like it. And then moved towards database technology because of I should prove that my stuff is working. And this is a really bad thing. If you should show that this is working. For this reason, I've moved to databases, to database theory first, to database implementation. We did also a lot on performance development of database systems and high performance.
DB square system, right?
Yeah, something like that. Yeah, DB square was a trial to have some kind of general tool for modeling. It is still applied and it's still heavily used. And for me, it is a very good source to see how people in practice are modeling. They are far more clever than I ever have thought. Mm-hmm. And they have a number of concepts you cannot even somehow guess. That is a good thing.
Mm-hmm. Yeah, I remember, you know, this book that you published in '91 that compiles all these different views on dependencies and so on. So it would be nice to hear this from you. What do you think was missing in the database theory that you thought you could capture by axiomatizing all those notions?
You know, at that time, we have had a belief that we can somehow represent a model by the syntax. And anything what does not go into the syntax is some kind of semantics, some kind of constraints. Later, we realized that constraints, at least on the level of first-order predicate logic specializations, are far too strict. We have been developing in the 70s and 80s, this is not my work, but work of others, a good number of constraints that are very useful, but not considered anymore. Mm-hmm. And one thing what I realized later is, even the notion of a functional dependency has at least 5 different aspects. Mm-hmm. And in computer science books, we teach only one of them. And the same is for valid for multi-value dependencies. That is a concept that we try to teach somehow the students, and nobody understands it proper because we are using the wrong language. Mm-hmm. And in this case, it should have some better, let's say, formalization. And nowadays, we have, of course, more sophisticated database management systems as object relational, with better structuring, with user-defined functions and structures. That means in this case, we should handle those things. This needs also revision. I'm dreaming about this revision after I got a glimpse on the foundations of modeling first.
Mm-hmm. Yeah, I think that's a nice testimony to the importance of logics as well. Terry also talked about this in his presentation. He said that the most useful thing he learned for his career was logics and philosophy. I mean, I think I experienced that myself several times, that there are some insights that you only have by thinking in terms of the logics and in terms of the formalization, right? The formalization would guide you in the right direction and would, let's say, yeah, you know, free you from some of your biases, right? And was that as well the path that took you from this more theoretical database work to conceptual modeling? Because I remember you extended this to cardinality constraints and path constraints and so on. Was that made you interested in this diagrammatic language in their semantics?
In my first really very large application case, the users told me, we do not need functional dependencies. We need real dependencies, real life dependencies. Please represent those. And then I was asking them, what is real life? Oh my goodness. This was really a challenge to represent them. And then we have also, I think the notion of cardinality constraints is very difficult to understand. Enrico Franconi did something in that direction, Maurizio Lizzarini as well, and especially Sven Hartmann did a lot on understanding. And then we found that some constraints are so bad that only the empty database or the infinite database is somehow representing all these constraints. That means in this case you have to have a very good handling procedure. And in my understanding, nowadays, logics consists of an integrated view on syntax and semantics at least. And integration means in this case, you should know on which place you should talk about what. And this is a different issue. Okay, but it's difficult. Yeah.
Well, yeah, we are trying to do something which, as you mentioned yourself, is describing conceptualizations of reality so that you can communicate and do problem solving and so on. So yes, that's difficult, right? That's one thing that I appreciate very much in your talk is that you make the case that conceptual modeling is inherently a interdisciplinary area. And that's what we try to show as well with this series of talks, right? And that there is so much to be done in terms of the theoretical foundations, right? It's much more than just sketching boxes and arrows so that you can derive some sort of implementation, database implementation. So that's really nice. Now moving to the higher order extended ER. So one thing that I like very much is that I know that you got interested in the formalization, in proposing an extension to a formalization of ER because of its industrial acceptance, right? Because it was accepted everywhere. It's very nice for a mathematician, a theoretician, to be sensitive to industrial applications and industrial importance. But I was going to ask you, so what is the main directions that you thought back then? So this was the beginning of the 90s as well. I know your book on this was already almost ready in the beginning of the 90s, although it was only published 10 years later. What did you think was that really needed to be extended in terms of the modeling capabilities and expressivity capabilities of ER that you took as a challenge in HERB?
I think that is a bit of a funny story. In the beginning of the 90s, I thought, okay, fine, let's look on all extensions somebody was making for the entity relationship model that are useful and have at least some reported success cases. And I found about 150 different extensions. So, and then I started to develop foundations, and I found very quickly that some of the extensions don't harmonize with each other. I do not have any chance to get a theory. Okay, I started to throw away things. Then I found a number of extensions. I will come in a minute back to it. And said are very useful and very really very useful for at least the application cases. And then I wrote this entity relationship book. In '93, I had a one-day tutorial at the entity relationship conference. I was very happy and went first to Heidelberg to deliver the entity relationship book. Okay, I gave the tutorial, and the evening of the tutorial, I thought, my goodness, the book is completely wrongly written. I went back to Heidelberg and told them in half a year you will get another version of the book. So please be patient, give me back the book, I will rewrite it now. It took me 7 years. What is essential? What is really essential, let's say, in a model, is to have a sophisticated representation of the features. Features can be also structured. Features are somehow maybe describing properties of represented in the data. That means we should have some kind of good structuring of features. Of course, in this case, we should go back to computer science again and say, okay, fine, a layered approach is the best way to do it. And then you have some kind of stratified layered approach so that you can see features. And then, of course, you have relationship types. And the problem is, in languages, we have also these SPO structures, subject, predicate, object. And you say, Pedro has a donkey. He beats him. Who beats him? That means in this case, you have now to represent Pedro has a donkey that is beaten by him. Okay, fine. In this case, you have now a structure that is based again on a relationship type. That means in this case, you have to have relationship types on top of relationship types. And of course, to handle it somehow, it should be again properly layered in a hierarchical structure. And then we found generalization and specialization is not the opposite of each other. Generalization is generalizing something to have a better, let's say, means to talk about it. And in this case, you need something for generalization. Specialization based on is-types, that will be a forthcoming paper, hopefully with Heinrich Meyer, is also something that is a specific form of specialization. We should have more sophisticated forms. And then we said, okay, fine, let's have some kind of notion for generalization. And at that time, we used the name cluster types. It means it is clustering a number of types, and you can abstract from those. You can say, okay, fine, a party in an, let's say, business activity is either an organization or a person. So in this case, you need, of course, to have this kind of generalization. And then we started with the constraints. Oh my goodness, this was now a very problematic story. Of course, you can use the negative results, for instance, that functional dependencies and inclusion dependencies don't have a maximalization. That is a result that is only the half of the story. It does not have a proper axiomatization inside the first order predicate logic based, let's say, on some calculi like Hilbert or Gensen calculi we are using. If we use, however, second order logics, that was shown by Hanula and Link, if we use second order structures, we have a very simplistic axiomatization of functional dependencies and inclusion dependencies. This was also a harmful thing for cardinality constraints, because of cardinality constraints have a minimal and maximal cardinality. They integrate a generalization of functional and of somehow inclusion dependencies. That means in this case you have to handle it properly. That means in this case logics behind becomes also somehow a little bit, let's say, difficult. Then you can say, okay, fine, I do it in a pragmatical way. I'm using a specific kind of cardinality constraint and the rest is skipped. If you need something else, please tell me in a proper form so I can use them. I think it's a better story nowadays.
Regarding this aspect of higher orderness, let's say, right? Higher orders. One trend that became more and more popular, let's say, in conceptual modeling in the past 10 years is this notion of multi-level modeling, right? So having instances which are instances of types, which are types which are instances of second order types, and so on, right? And this pops up in many different domains, obviously in biological taxonomy, but also in product modeling and in many other things. So if we look at databases in practice, I mean, this is, it's everywhere. It's ubiquitous to have this kind of higher order phenomenon. So can you say something in that direction? What's your perception of the challenges there, and if yourself you think you did some work in this direction?
I did a little bit of work with a MOF hierarchy. With the forthcoming paper with Heinrich Meyer, we will have some treatment of that. That is one way to say, okay, fine, you have an abstraction means. But the problem is, in the MOF categories, you have only an abstraction based on some kind of language definition. You define something on top of something, and then you have maybe the MOF levels at 4 that says, okay, fine, you are using a mathematical language. And that is only one kind of abstraction. you have also to take into consideration that a model typically has as an origin also a model. A conceptual model has an origin, for instance, our perception or mental model, or a domain situation model. And in this case, you have models based on models. And this can be continued. And now going towards, let's say, the classical, let's say, realization, then you say, okay, fine, my model should be also the basis as a blueprint for implementation. Then you have to use a system model as a basis of your conceptual model. And in this case, you have, of course, to represent your understanding how the system works in this case. That means, again, you have another kind of combination of models. That is a construction theory. I think still it is a good thing not to limit yourself on having a model based on a modeling language, that is again based on a modeling language approach, based on that is again based on a mathematical approach. You have different levels. You have the abstraction levels, you have the based on levels, and you have the resulted in levels as abstraction hierarchies. And this, I do not know any book. I know a number of publications, but I do not know any book that somehow attracted back to some kind of database course. But I think we have to have it somehow. And of course, you are not considering only a structure model, you are also considering a process model.
Of course.
Or maybe a control model or something like that. In this case, now you have to harmonize all these different ways to represent something. And this is still a very big challenge.
Yes. I mean, so there is this aspect of higher orderness, which goes to the meta and meta level, which is one aspect. But there is also this other aspect in which you have higher order types as domain elements, right? So the donkey in your story is an instance. So the donkey that someone's beating, poor donkey, is an instance of a donkey species. And this donkey species, you would like to predicate things over it as well, saying, you know, that this is common from originally from North America, that has a particular life expectancy, that has a kind of migration pattern and so on. So this idea of having types as instance inside the domain model, right? Okay, so I have the feeling that, and this, you know, it's nice that in your talk you were stressing some other aspects, which I think are kind of neglected in historically in conceptual modeling. In one sense, we computer scientists, we do, you know, most of our work tends to concentrate on syntax, right, and on formal semantics, because this is basically mathematics, right? So it's basically mapping a piece of mathematics to another piece of mathematics. So I'll mention 4 areas in which I think there is a lot to be done, and it would be nice to hear your opinion on that. So the first one is this notion of real-world semantics. So the semantics which really binds the things in our language to the things they are supposed to represent in reality, right? And you mentioned one aspect of this, which is the conceptualization, so the engineering of concepts. I don't know if you're aware of this. There is this area in philosophy now. It's called conceptual engineering, and conceptual engineering. Concept engineering, concept engineer or conceptual engineering, which you know, in the words of Dave Chalmers, which is a prominent philosopher of mine, he says conceptual engineering should be understood as the design, implementation, and evaluation of concepts. Right? It's not the word that you normally hear from a philosopher, implementation and evaluation of concepts, but this idea of really engineering of concepts. So we just take, I have the feeling that we tend to take concepts as unary predicates, right? And of course, from a cognitive point of view, this is not the case. I mean, we have a concept for table and for chair, but we don't have the concept for the left side of the table plus the right side of the chair or something like that, right? So could you comment on this, on the need for foundations for engineering concepts and this aspect of real-world semantics?
With real-world semantics, I had to learn from my people in philosophy of science and in philosophy in general, and also in statistics about the source of Platon. It goes very, very far back, but Platon had three analogies. One I mentioned, that was an analogy of the cave, but he had also an analogy of the sun. And in this, he said, okay, fine, we can only think about what we are what we see, nothing else. And this gave me a bit of depth in what I'm doing. He said in this case, my goodness, we have now not the real world, and this was for me a shock, not the universe of discourse, but what we understand of that. That means in this case, we have some kind of reality models we are starting with, and some kind of reality understanding. And if you think about very simple concept, what's the name of a person? Why you should name a person by family name and first name? This is our, let's say, European understanding. My goodness. Mm-hmm. The rest of the world ticks in a different way. That means in this case, we have now our, let's say, our perception, our imagination, what could be the real thing. And in this case, I think conceptualization and concept engineering does it partially nowadays, is something else than we think in our, let's say, implementation-oriented approaches at least. And I think we should have some kind of glimpse for that in a proper way. And I think this will be, I think we will anyway attract a lot of people from these areas, and then we will see what they think about our concepts. I have in my, let's say in my memories, one of the discussions with people from economics, when they told me, you have so naive thoughts about what's the model. You should not talk anymore to us. And I think the guy was really, let's say, to a certain extent, even right. Unfortunately for me. But anyway, this is maybe a way how to handle those things in a proper form. It's a long story, but anyways, that's maybe a part of the story. And of course, let's say, in my understanding, conceptual modeling is at least 4,000 years old. We have to capture all these kind of approaches. They are very clever partially. And in this case, we should really look how to handle those things in a proper way. And I think that is far away from handling it nowadays. And okay, it will be again a challenge for us. Mm-hmm. And I think all these really things could be somehow represented also in a proper way.
It's interesting that you mentioned economics, because economics is also coming back to its origins, to its conceptual origins in a sense, right? So economics into the 20th century or into the 19th century was basically applied philosophy, right? So all these guys, Marx and Smith and Mill, they were doing philosophy work. And then economics in the 20th century, due to physics envy, went in this direction of these mathematical quantitative models. And then you end up with equations that can calculate risk, but people cannot answer the question of what risk is. Right, so they are going back in that direction, which I think a very interesting, development in economics as well. The second aspect that I think it's being neglected, and I know you were very interested in that topic when you were doing your work on web information systems engineering, is this aspect of pragmatics, right? And by there are many things which would fall under pragmatics, but I will mention two. One is the, let's say, visual pragmatics. So concrete syntax, visual syntax is something which is kind of almost ignored in conceptual modeling. And the second one is the aspect of pragmatics, which is this unwritten rules that modelers use to communicate with other modelers. So for example, in CAD design, people arrange design in a certain way to signal to other modelers that they are experts and that they know what they're doing and so on. So in a sense, pragmatics is the semantic outside the semantics, right? So could you say something about this, the challenges in pragmatics of conceptual modeling?
When I have been discussing the modeling issue with semiotics people, they told me again a bad lesson, is that I don't understand semiotics properly. Pragmatics is something else than pragmatism. And since then, I'm a little bit more careful with the notion of pragmatics. Of course, let's say you want to have at least a system that works with a user. When we have been developing web information systems, we realized that the user viewpoint is a real, let's say, argument for accepting a system, and nothing else. That means in this case you have to meet the user understanding, and this is pretty difficult. And additionally, we are sometimes thinking that we have only to consider some kind of formal language. No, the visual languages are very good means, and in my understanding, visual languages become before natural languages, and we draw first and later we write. That means in this case we have maybe a number of visual languages, and visual languages can be very sophisticated and a very good means to express something. And when I think about models, that is a little bit crazy, and you will kill me now. I think the model is coming even before the language for humans. That is, let's say, my understanding of that. But maybe that is because we try to have some kind of understanding, some kind of, let's say, perception and thoughts, what we observe. And in this case, we should also consider those viewpoints with any of the other sciences. The problem is, of course, we are still struggling with the foundations of conceptual modeling in database research. And we should also concentrate on those a little bit more, but and not to go directly for the general case. But anyway, this is also a very useful thing to think what we can do with such kind of conceptualization. And the problem is, of course, also the concept spaces and the cultural background matters. Think about a simple thing as a concept of time or space. Let's say in Japan, space is completely different than in Greece. In Greece, you enter a queue being as close as possible to somebody else. In, let's say, Finland, the distance was before Corona, even 2 meters you have to have there. And this is a normal queue. That means in this case, you have already a different concept of space and time, depending on the culture. Or think about the word no. Oh my goodness, this has so many meanings in different cultures. And now we have to map this user culture to our understanding what should be done in the system. And in web information systems, for me, it was the first point where I saw really the bad impact of our system orientation.
I remember that you mentioned web information system. I remember the story that you told me that you started working on this almost kind of by accident. This became so popular from an industrial point of view that in the end you carry out the research along this line of research because it was basically financing your group, right? Yeah. So can you say something about this experience of the technology transfer in that area?
This was a funny thing. In my former university in Cottbus, we didn't have sufficient money for even financing to get an update of our systems or to buy the update. For this reason, we had to earn some money. And then our mayor of the city decided that we should have a representation of Cottbus because he wanted to do a very large garden show for Germany. And he needs a proper representation. And then we started to build a region web information system. And we learned that the user has a completely different need in information. And it is very difficult to meet these needs in a proper form. After we understood it, we realized that this was becoming somehow even a business of the group. In the final end, when I left Cottbus, it was for me very difficult to get rid of all these web information systems developments. We did it for educational systems. We did it also for identity systems, for business web information systems. It means in this case we have been covering all, but it was very hard to get away from those things. At that time, we realized, however, that a typical web information system does not consist only of, let's say, 50 web pages. A typical one consists of 1,000 web pages, where maybe some of them are even similar to other pages because you represent different users in a different way. So in this case, you have somehow to have a generating facility. And then we have had to develop some other modeling of what a user really has in mind and what is really a story. And that is a bit of a story.
Yeah, I mean, this touches another point that you mentioned in the very end of your presentation, which is, of course, this topic of complexity management of large models, right? I'm very interested in that, kind of obsessed with this in the past years, because I also think this has been somehow neglected in conceptual modeling, which is how do you, and it's also an aspect of pragmatics and cognition, right? I mean, if you have the computer manipulating models, it doesn't matter if it has 100,000 concepts, but if it's a human, and if the purpose of the model is serving as a contract for interoperability, how do you guarantee that this person even understands what this model is representing, right? So there's different aspects of complexity management. This seems to be something which is also missing in the foundations of the area. So can you say something about that?
Yeah, I'm collecting a little bit what has been done in practice because of these tools we have been developing and models I'm collecting especially, and look what users do. My largest model I have so far consists of almost 100,000 types, attribute, entity, and relationship types, because I was somehow forcing people to think in this manner. For this reason, we have been mainly represent plus cluster types. 100,000 is far too much. And psychologists, at the time when we developed web pages, they told us that a user has not more than 30 concepts in mind whenever he is tackling a web page. Oh my goodness. 30 against 100,000 is something that is really different. Yeah. And of course, the user has a complete different understanding what is maybe, let's say, a simple thing like an address. That is not only different in different cultures and countries, that is also different in the understanding of people. That means you have to listen what you really want. And in this case, you have to try to map. The first implementation of addresses, for instance, in SAP R3 was to have 75 different tables for representing addresses of a human. Of companies, additionally, another 100 tables. And all these should be integrated. Of course, that was a difficult challenge to integrate this thing in a proper way that this is running in the system. Mm. So in this case, you have to have a very different way of representing things and of, let's say, proper understanding the application area. So this is a thing, of course, this can be only done when you are somehow doing a lot of projects. Mm. Of course, you can be lost in projects. I know that is
Bernhard, I will move to the questions from the audience now. So the first question is, in which scenarios do you think conceptual models create more value for organizations?
I think as a first, where we have really to have success stories is if we are using conceptual models as a prescription for developing systems. And the next step will be a dream. I'm still trying to have with a number of my colleagues that you use models as a generation input. You are using the model and generate the implementation at least in a template form. We can do it partially in the database area, that we use a conceptual model based on maybe an enhanced or extended entity relationship model, and then we generate some means for the implementation. But you should have much more, because if the systems are providing you, let's say, indexes and some user-defined stuff in a proper way. And in this case, you have to have some kind of generation facility. Nowadays, some people try to have something like models to program. My dream is to have in the next, let's say, decade, models as programs. That means you don't program anymore, you have the model and they say, okay, fine, dear machine, do it. That will be a very good success story. And my belief is based on a very simple thing. In the 19th century, civil engineering and machinery was built on standardization. And now you can repair anything having these standards for screws, for instance, and buy a screw, say somewhere in Brazil, and be sure that this is working with your machine in, let's say, in Twente. That is, and I think we will have it in the future as well. This will be, of course, some maturation of computer science, but this will be a real success story.
Yeah. This is what, Oscar, you should call extreme non-programming, right?
Yeah, okay, fine, yeah.
Do you see textual languages as an option to help with conceptual modeling expressivity? Have you seen interesting textual languages in the past?
Textual?
Yes.
Yes. We have been trying, when we have been building tools, to map narrative stories or explanations to conceptual models. And after drawing this entity relationship diagram, I went to our librarian and said, okay, fine, now we have the library database schema. Please tell me whether it is appropriate. The funny story was, she was liking this kind of graphical representation, and she told me, this is wrong. This type is wrong. I said, my goodness, what is wrong? Oh, there is also something wrong in the text. Oh, we should do it in a different form. And I think we are far more or far better able to think and to write something in our natural language. We learned it for a long time, and for this reason we are better able to do that. That is also the problem of being lost in translation when you use a different language than your native language. And in this case, I think a textual representation will become really a cornerstone of even conceptual modeling in the future. And you will be happy that you say, okay, fine, I can map anything to ontologies nowadays. I will be happy, I say, okay, fine, I can map anything to advanced or somehow entity relationship models. That will be, I think, a part of the future. But natural languages are a very difficult matter. They have idioms, and idioms are somehow shortcuts, but sometimes an idiom has a complete different meaning than the words in the idiom. So we should take care of such things as well.
Yeah, Christian Feldbaum wrote an entire book on this, on idioms in German, right? But I think it's an interesting point to highlight that, for at least in my view, and I think you agree with that, having a visual concrete syntax is not a prerequisite for something to be a conceptual modeling language, of course, right? Yes, I mean, I can think of examples like, concept base and telos, taxon in the beginning of I think in the 80s, right? With John and Alex. And okay, so the next question. The discrepancy of the semiotic triangle is that many concepts are not observable. That is, they only exist in the minds of people such as God and fantasy and so on. How do we approach modeling unobservable concepts?
I think we have two different sides to consider at the moment, at least. We have to have some kind of understanding of mental and especially perception models, what you have in your mind. And nowadays, neuron theory says that we have completely different understanding. To have a completely different understanding than only neurons in the classical coherent sense. That is maybe one thing. And I think the other thing is that we have to have some kind of, let's say, understanding of an application domain. And for this reason, I like to use domain situation models as a representation what we have in the application domain as a settled understanding of the application. If you go to a business application, people have an understanding what is, let's say, a parcel. Of course, my understanding of a parcel is completely different from their understanding. That means we have to integrate the two different sides, what we think as a human in mental or perception models, and what we use or reuse from already given models. And in this case, we have, if we can handle this integration in a proper form, even automatically, then we would be in a very happy case for our systems. But this will be the future. And one word more. Typically, we are not using only one representation of a model. We have, of course, a diagrammatic way to represent the entity relationship model, but we have also a formal way to represent it in some way. And sometimes you can say, okay, fine, the formal model is an underpinning of the diagrammatic representation. And also visualization has, as well as any language, a number of limits, and so we should consider those as well when we are handling different models. Think about a very simple concept of an event. If you go to the Hopi Indian tribe in America, they have completely different understanding of an event. We think an event is somehow state-based, and we can map it now to some kind of state-based, let's say, transformations. Not at all in the Hopi Indians tribe understanding. That means in this case we have somehow to have.
I'm obsessed with events as well. What is their understanding?
The Hopi Indians, they have no concept of state. They have only a concept of change.
Okay.
And this was mentioned by Sapir and Worf, some kind of syndrome, I would call it, but this is my let's say, word for that. And they said, okay, fine, it's not possible to translate what the Hopi Indian tribes people say to us and what they say to them, because of they are not state-based. They have no state-based reasoning. They have only changes.
Which means in their language they don't have nouns, for example, or proper names, right? It's just verbs.
No. Even let's say very sophisticated verbs. And
so instead of chair, you have chairing or something like that.
Yeah. Currently chairing.
Yeah.
That is the same what we have also in Far East languages, like the Japanese language. You don't point to yourself. You say, I am chairing. Or chairing, I am. It's a reform.
Could you talk a little bit, so again, about the relation between conceptual modeling and programming? Could you talk a little bit about your view on what is next in the next generation of programming languages, and will conceptual modeling play an important role in them, in the next generation of programming languages?
I'm pretty sure that it will play a very important role if they are able to translate our concepts, or let's say at least the representation of concepts we are using to proper programs. They will play a proper role. I think we have now 4 generations of programming languages. The 5th generation project failed, not because of it was bad, but it was too early. I was talking to the 5th generation people in Japan, asking them why it failed and try to guess what happened at that time. And they agreed, at least on my understanding, that it was far too early to tackle this problem. But we will have languages that map a normal, let's say, statement a user makes to a program that runs a proper, let's say, or provides a proper solution to the question maybe somebody was asking. Depending on the different systems. You can also have some such things nowadays using some kind of WordNet mappings and anything else, but the need is far more sophisticated.
Yeah, yes, I mean, it has to do with this issue of real-world semantics as well, right? I mean, the semantics is not, it's the Chinese room of John Searle again, right? So the semantics is not the computer. You have to translate a certain conceptualization of the world into a representation, and someone else has to interpret that after manipulation. But also, not only that, is that a program involves necessarily some sort of conceptual modeling, and it's a device of communication between programmers. I really like this quote from Donald Knuth. He says that programming is the activity of telling the other programmer what you want the computer to do. It's not about telling the computer what you want the computer to do at all, right? Otherwise, you would write in machine code.
We are still in let's say in developing in the development of languages that can be properly handle such things. And the problem why we go away, let's say, from C or C++ towards maybe Python or Ruby on Rails or whatever you can have, is because we want to get closer to the user, and we want to have a simpler means for the layman programmers. Yes, they can tell you what they really want.
You have mentioned the issue with layering, M0, M1, M2 in the OMG sense in conceptual modeling. Are you familiar with the multi-level modeling community and the work of Atkinson and Kuhne from early 2000s. So this is Thomas Kuhne and Colin Atkinson.
Yeah. I think I'm reading these papers at least once per year to understand what they have really in mind. The multi-level modeling approach is a pretty nice approach to get rid of the strictness of the MOF layering. And I think that is on the right path. But still, we do not know the real instruments to handle it in a proper way. That is maybe something in the future. And it is not only multi-level modeling, it is also multi-modeling in an integrated form so that we can rely on one of the models and say, okay, fine, this is finished, this part is finished, we don't talk anymore about it. This will be also a challenge.
Yeah, that's another issue, right? This issue of when you have several different models and several different modeling languages, the whole issue of viewpoint consistency and so on, right? Thank you very much for the inspiring talk. For some years, I'm trying to persuade my students and colleagues to use conceptual models for building better database schemas, but they still think that conceptual modeling is a redundant step. They better build a database while thinking in terms of tables and columns, then change it if required. The majority does not see conceptual models as an instrument of the first step analysis. What would you recommend to argue in favor of conceptual models to people with such an attitude?
I think this is one of the mistakes we have been making in the past. We said a conceptual model is an abstraction of a so-called logical model. And in reality, a logical model, what we consider in the relational form, let's say, is already a conceptual model. Maybe with a little bit more simpler semantics, with a little bit more simpler concepts, but it is a conceptual model. And it is a big failure to talk to people to say, okay, fine, now you have to change your mind. Your models are not conceptual models. In most cases, they are already conceptual models. And that means in this case, I think we should be a little bit more, let's say, a little bit less eager to apply our, let's say, language, or to somehow to concur their language by our notions. When we have been talking in our community in Kiel with a lot of different people, what is in this case a model, or in their case a model, we have had a good number of sessions. It took us 4 years each Tuesday. Then they have been explaining what is in their understanding a model. And after getting this kind of understanding, the state, okay, fine, in your case, it is given in this way, with these words. And this is now a little bit, let's say, an anti-religious statement. I think we should be far more flexible with our, let's say, religious concurring the world approach to say, okay, fine, a conceptual model is only what is given in one of the conceptual modeling languages. We have a number of competing conceptual modeling languages, and we should be able to handle those things in a proper form, and especially if we are talking about applications. And for this reason, maybe we do it a little bit wrong that we, when we teach conceptual modeling.
Your image got frozen there for a while, but I'm glad you're back. I think it has to do as well with this issue of another area that I think it was a bit neglected in conceptual modeling is this issue of the need for some sort of execution semantics, right? Because you were right. I mean, when people are doing building database or when they are doing programs, one thing which is very important there is that they can get immediate feedback about what they are doing. So you build a program, you run, and the program tells you if you're right or not. The same thing with a database. You build a database, you can do queries, and you can manipulate things in there. And in conceptual modeling, I think it really makes a difference when you have some sort of operational semantics, execution semantics, in which you can see the model itself coming to life. Would you agree to that?
Yes, I'm definitely agreeing after having this bad web information systems experience. This is, I think we should do more on such kind of fly-in applications, or how it was called by Harel, play-out applications.
Exactly. Yeah, come out and play. Yeah, David Harel. Yes. Yeah, I fully agree. Interesting question here. Does concepts exist outside the minds of people?
The answer should be yes. The problem is only we are very selfish and we consider only what we understand under concepts. In reality, there should be some concepts outside what we have currently in mind. Currently in mind means also what our community has currently in mind. Let's say if I have a concept of an account in a bank that is commonly agreed in the banking business, and I have to agree with that. That is also a concept that comes, but it is also in the mind of people and can be minded somehow. I think we have to go back to maybe ancient Egyptology. So in this case, you see that there are some concepts we don't understand yet. But there are concepts somehow. Think about a very simple thing. In these palaces, you see an ear. That is, please God, listen to me. Currently, this is our understanding. I think we have something, but for our, let's say, issue in computer science, we don't need concepts outside our mind. For this reason, we can handle those.
What's your view about conceptual modeling in the future? I mean, in which aspects the community should work for developing an ideal conceptual modeling process? If I can add to this question from the audience, you know, we have many students here. So if you had to recommend a topic in which someone should take up as a PhD thesis topic, what would that be?
Oh, we have, let's say for a PhD topic, I have been providing some of my, let's say, dreams. But let's say for what should be really, let's say I have, at least for our community, a dream to have a module in each computer science course called modeling. That would be, let's say, a big step forward already. Of course, in this case, we need to have some kind of agreement in the community. And I think we should all be aware of that we are all the time modeling. You, let's say you walk on a street and you have a model of somebody that is coming to meet you. You develop immediately a model. This is also maybe a conceptual model even. In this case, you have already something, and we should be aware of that we are doing it all the time, maybe under a different name. That is the part about we should not conquer the world with our notions, but in reality, we are modeling, and we should be aware of that, and we should be able to handle this kind of modeling on the first impression. That is modeling on emotions.
Yeah, I mean, if we take modeling, not just the representation part, but the abstraction part, without abstracting, we can't even focus perception, right? So there is this very interesting experiment called the gorilla in the room, a very nice paper in which, you know this, right? The basketball game, the gorilla enters, people don't see the gorilla because it's not part of the context and the goals, right? They have there. Bernhard, you were the first person to win the Peter Chen Awards. How did you feel in that occasion? I was there.
Oh, this was a big surprise. It was good that the community kept it until it happened, because I knew that something is going on. There was a call because I was in the steering committee, and for this reason, of course, I knew that something is going on, and I had a good number of candidates for the, let's say, Peter Chen Award. And it's that moment when I got it, that is something like it came from somewhere. And you have some pictures. You see me that I'm not emotionally, let's say, I went to a different emotion mode.
I can imagine. Okay, great. I think we have to wrap up. Thank you very much, Bernhard. This has been great. It was great having you here. Thanks for giving this talk and answering all these questions. Thanks a lot.
Thanks for the organization.